Good evening, my fellow hackers. My name is Braindead. I train every day, one try hack me room, one new skill, always ethical, and by 30, I'll be a professional hacker. So, I wanted to discuss server side request forgery today. In my previous day 30 room, I attempted to do a hard level room called extract, and one of the main concepts that we had to go over in this room to be able to retrieve the first flag was server side request forgery. So, being that this is such a fundamental concept, and I feel like it's a very powerful mode of entry, I think it'd be a great idea if we went over server side request forgery together so we both can understand how this vulnerability takes place. So the abbreviation is SSRF. I'm going to read out this mission statement here, and I have the room starting up. So let's get into it. So, the landscape of web attacks constantly evolves, with threat actors devising sophisticated methods to compromise systems. As each day passes, the expansion of web-based threats warrants the need for robust cybersecurity measures to counter the ever-advancing tactics employed by malicious actors. In this room, we will discuss a similar attack known as server-side request forgery. Server-side request forgery is a web application security vulnerability that allows the attacker to force the server to make unauthorized requests to any local or external source on behalf of the web server. And in my attack box, in my previous video, I was using their open PDF function in JavaScript to it was calling the web page for the PDF in their web server. So I was actually using it to obtain further access into the web server. That's how I managed to get onto the web server on port 10,000 for that management room. And that was a key beginning step for that penetration. Anyway, let me continue. SSRF allows an attacker to interact with internal systems, potentially leading to data leaks, service disruption, or even remote code execution. I could definitely see how I could have kept going further there. It actually stopped. I was kind of expected to somehow find a way to reverse shell back deeper into the web server, but I never got that far. The room just ended. Learning objectives: understanding the workings of SSRF, practically testing various types of SSRF, few important tools, and key mitigation, right? All right. So we are going to go to... I might have to open my Kali machine here. Now let's see what is the first step. So let's make that bigger for everyone. When developing networked software, it's common to make requests to external servers. Developers often use these requests to fetch remote resources, like software updates or import data from other applications. While these requests are typically safe, improper implementation can lead to a vulnerability known as SSRF. And let's take a look here. So we're going to the web server. The web server makes a request on behalf of the user. It goes back. Boom. But if I were to just go right to the you're impersonating the web server. Very cool. So an SSRF vulnerability can arise when a user-provided data is used to construct a request, such as forming a URL. To execute an SSRF attack, an attacker can manipulate a parameter value within the vulnerable software, effectively creating or controlling requests from that software and directing them towards other servers or even the same server. SSRF vulnerabilities can be found in various types of computer software across a wide range of programming languages and platforms, as long as the software operates in a networked environment. While most SSRF vulnerabilities are commonly discovered in web applications and other network software, they can also be present in server software. Right, it's a formidable security target, or threat rather, and it's part of the OWASP top 10. Okay, so very Very important. It ranks 7 in the OWASP API security top. All right. Data exposure. As explained earlier, cyber criminals can gain unauthorized access by tampering with requests on behalf of the vulnerable web application to gain access to sensitive data hosted in the internal network. An attacker can carry out port scanning of internal networks by running malicious scripts on vulnerable servers or redirecting to scripts hosted on some external server. And that is exactly what we did in the previous room. Is we utilized port scanning. I was able to scan literally each port. And I basically was trying to figure out which ones was giving me the most words or characters in the response. And when I was able to figure out, anyone that wasn't valid was giving me 0 words. And on port 10,000 and port 80 were the only ones where I received more than, I think I received couple, maybe 1,000 words for each one. What is the average weighted impact for the SSR vulnerability as per the OWASP top 10? So, types of SSRF. Basic SSRF is a web attack technique where an attacker tricks a server into making requests on their behalf, often targeting internal systems or third-party services. A basic SSRF can be employed against a local or an internal server. We will discuss both scenarios in detail. Scenario 1. In this attack, the attacker makes an unauthorized request to the server hosting the web application. The attacker typically supplies a loopback IP address or local host to receive the response. The vulnerability arises due to how the application handles input from the query parameters or API calls. For example, in the HRMS application, there's a feature that loads additional pages based on a URL parameter. For example, navigating to hrms.thm $URL equals, this is exactly what the parameter was, localhost / copyright, would load the copyright page of the application. However, due to insufficient validation of the input URL, an attacker can manipulate this functionality for an SSRF attack. For instance, if the attacker uses a URL such as localhost / config, and config is a valid page, the HRMS server will attempt to fetch content from this page and display the result. Isn't that very cool? Wow, that's just fascinating how it does that. Suppose you've been tasked to pen test the HRMS website and identify any SSRF loopholes, and you will see that the login page is protected through a username and password. We notice that once we visit the page, it automatically redirects to that. The web page shows the copyright status. Wow. This means the developer has probably made some mistakes while handling a file showing the copyright status. Here's the code of the page that takes the query parameter. If file exists at path is the root. Oh, get URL. Echo HTML special characters, file get contents, echo pre. This is not found. Okay, so file get contents is essentially what the issue is. We can see the above code that the input parameter URL lacks adequate filtering and loads whatever the parameter is provided from the local host. Let's try to change the URL from HTTP copyright to localhost / hello. It displays an error that hello.php is not found. So the page calls another PHP file and displays it on the current page's footer. Interesting. What if we call sensitive files, like connection or config? When we try to access the file, we'll see that the footer of the page shows the content of the file, essentially showing us the exact credentials, which would look like this. What is the username for the HRMS login panel? So let's take a look. HRMS.thm. I did not put that in my Etsy host, so I don't know why that would work. Let me put that in my... I'm not even in Cali, actually. I'm not even in Cali. Great. Okay, so let's go to my Etsy hosts and type my correct password. And we are going to add this to HRMS. Great. So now, boom. Now we should get a website. And this time, we're getting, and it kind of spelled exactly what we wanted here. So, config. And look at that. We got, it's really cool. That's pretty sick. Now, I'm guessing I should be logging in. Okay, I think I was right with that assumption. So we are just going to, what is the username? Do I really have to put in all of this? You could have just asked me for the flag. That's all right though. I might get more points for more submissions. Hopefully that's the idea. Now, I don't know what the password was. HRMS admin 123. Dang, I don't remember what it was. Not a capital, right? I really should just go back. Dang it. All right. HRMS. Let's go back. Okay, this has my cookie saved. HRMS. Don't worry. HRMS. Fourth time's the charm. Alright. Config. And I was way off. Boom. And what is the... Do I really need to go that hard for this? Okay. Boom. What is the admin URL as per the config file? Oh. That's, I feel like it's even shorter, but I guess it wasn't. Okay. Type of SSRF continued. In complex web applications, it is common for front-end web applications to interact with back-end internal servers. These servers are generally hosted on non-routable IP addresses, so an internet user cannot access them. In this scenario, an attacker exploits a vulnerable web application's input validation to trick the server into requesting internal resources on the same network. They could provide a malicious URL as input, making the server interact with the internal server on their behalf. For instance, if an internal server provides database management or administrative controls, the attacker could craft a URL that initiates an unintended action on these internal systems when processed by the vulnerable web application. Technically, this is achieved through manipulated input, such as special IP addresses like 192.168 or 10 for IPv4, or domain names like internal-database.hrms.thm. When not properly sanitized, these inputs can be used in functions like HTTP requests or file inclusions within the web application. I can see that. The server interpreting these requests as legitimate then inadvertently performs actions or retrieves data from other internal services. Moreover, since these internal servers may lack the same level of security monitoring as external-facing servers, such exploitation can often go unnoticed. The attacker might also use this method to perform reconnaissance within the internal network, identifying other vulnerable systems or services to target. In this case, we'll try to access the inaccessible internal resources through direct request. Now that we have acquired the credential for the login panel, we'll log into the dashboard. Once we log into the HRMS web app, we will see a dashboard listing employees and their departments. There's a drop-down that shows employees' data and salary. And let's log in there. Boom. All right, continue. And I think it wants me to go by salary. Oh, but it's blocked. I see. Host show an error. Oh. Oh, so it wants me to get to the admin file using server-side request forgery. Now, I kind of want to just try it myself before looking. Let me just see if I can try it without looking. So if we go back, oh, actually, I don't know how would I do this going backwards? Let me just try it. Delete. Server not found. Then I might have had to get the salary page. Okay, let me get the salary page. Localhost config. And let's go back here. Oh, I should probably just read the article rather than jumping the hoop here. Okay, yeah. Jumping the gun, rather. Once you update the value, choose the salary option from the select category. Here we go. We got the access panel to the admin panel that was earlier inaccessible from the same IP. As shown below. Oh, am I just going into my cookies and modifying it? This is what it wanted me to do, right? Get info.php, huh? I don't think I'm doing this right. What? Elements. What? Oh. And then it wants me to change this as admin? But why would this work? Aren't I just changing? Once you choose it from this. Here we go. We got the admin. I don't understand why that would even work. Salary? Employee? Salary? Employees. Salary? Employee? Oh, was I already in? I think I shouldn't have been in it. Okay, it's definitely here. Oh my goodness. Table class. Oh my god, table. Table. I don't need table. I need to go higher. Is this it? There we go. Admin.php. And then which is just crazy. That's interesting. It loaded it, which I don't know why it would load it from like that. That's interesting. Okay, so that was the flag. If possible, yeah. Nay. Blind server-side request forgery refers to a scenario where the attacker can send a request to a target server, but they do not receive direct responses or feedback about the outcome of their requests. In other words, the attacker is blind to server responses. This is a type of SSRF can be more challenging to exploit because the attacker cannot directly see the results of their actions. We will discuss its various examples. Out-of-band SSRF is a technique where the attacker leverages a separate out-of-band communication channel instead of directly receiving responses from the target server to receive information or control the exploited server. This approach is practical when the server's responses are not directly accessible to the attacker. For instance, the attacker might manipulate the vulnerable server to make a DNS request to a domain he owns or to initiate a connection to an external server with specific data. This external interaction provides the attacker with evidence that the SSRF vulnerability exists and potentially allows them to gather additional information such as internal IP addresses or the internal network structure. Once we log in to the dashboard and click on profile, and that we will see that it redirects to, which displays a message that data is being sent. What's happening here? Once we load profile.php, it sends data to an external page named get.info.php, which is probably used for analytics or logs. Shows it's reading the URL parameter. On your attack box, create a new file called server.py and add the following code to it. Is this the proxy? I don't know. I don't know if this is the proxy. If that's the proxy, that makes a lot of sense why they would know how to make this. Nano test proxy. I'm going to actually make a... The above code will receive all the contents and save it to a file data.html on the server. To obtain the data, we first need to start a lightweight server. We could do this attack in the attack box. I need to sudo this. So let me go back here. Nope. Why did it not copy what I wanted? Oh my goodness. Whatever. Oh my god. Go away. If else. There. Okay. Jeez. Plus X test. That one was a Python 3. Is that what it wanted me to do? So I just started the server. This makes so much sense. Now, seeing it, okay. Hopefully that copied. Good. Dude, this makes so much sense now. And so I got the analytics data. I'm just gonna strings this. Wow, this is like way bigger than I had. Wow. I don't think I have to read this. Hopefully I don't. Does out-of-band server-side request forgery always include a technique in which an attacker always receives direct well, it seems like there's the blind. What is the value for virtual directory support on the PHP server per the logged data? What? Dude. How am I supposed to read this? gotta be kidding me here. I wonder if I could just open this web page. I'm just gonna open the web page. That is insane. Okay, that's probably easier to read. What did it say? What is the value of PHP? I don't know if this is the answer. I'm just gonna... What's the value for virtual directory support? What even is virtual directory support? Oh. What is the value? What do I really... Oh, wow, I just had that one too. What type of Alright, what type of SSRF doesn't give blind? An attacker could abuse SSRF by crashing the server or creating a denial of service for other hosts. In the SSRF demonstration, we'll illustrate how an attacker could exploit a web application to cause DOS on the server. In our scenario, the vulnerability is exploited by supplying a malicious URL that points to a resource, which, when accessed by a server, leads to excessive resource consumption. Okay. We'll see a tab called, which shows training content. We notice that the URL.php is loading external content displayed here. What if we try to load any other content? Great. It opened the file for you. That was nice of them, I guess. I don't know if it wants me to, I'm just gonna save that. Now that we know the server is vulnerable to basic SSRF, let's explore the code of URL.php to make it crash the server. Ah. Download and encode image. If the image exceeds 100 kilobytes, it shows a memory outage message and throws an error. Okay. Wow. Where's the flag after loading a big image? Oh my god, look at that. That thing's screwed up. I didn't actually need to. Mitigating. Which of the following is the suggested approach while handling trusted URLs? I knew it was B. It wasn't B. It must be B. I knew it was A. What do you mean? What are you talking about here? It's B. All right. Thank you for joining me on that quick study session on SSRF.